has a relationship to other classes. It could be the inverse of another class. It could be connected by being a section of another class. It could do all these different things. All you have to do is use some kind of linking phrase to connect these together, and you have a triad. And this triad is the basis of what makes up an ontology. So all of these different triads have to be coded or just put together in order for an ontology to be developed. But when that ontology is complete, the power of what you can do and how you can code with this ontology is absolutely amazing. Here, I want to show you guys a couple of companies that use these ontologies to mine data in the internet and create some of the most amazing websites that every single person in this room uses. Websites like Google and Facebook. Google and Facebook's coding processing power comes from their own ontologies. And these ontologies grow every single day as people add data into Google and into Facebook. Search terms, search results, new web pages, things that people share, things that people like, personal items that people message, pictures. All of these things are different classes within these ontologies of Facebook and Google. It's how they're able to track you, create your own personal profile, do all these amazing things with all of these big data. So how is all this big data going to help food? You can see that what we can do with these food ontologies is create these massive maps. And specifically with what I'll be working with my food-drug interaction ontology, is how we can create this map to define and characterize all different kinds of food-drug interactions, whether they are these adverse ones like I mentioned, or whether they are ones that can be beneficial or neutral. And what that does for Took That Eat This is it allows someone to have a very personalized map of what they are eating, what medicine they are taking, how they relate to each other, and how the foods can be, and how you should possibly avoid these foods, or how you should possibly consume these foods. Because this ontology connects so much more than just an ingredient in food, a drug, and a reaction. It connects a person-specific disease state. It connects the specific ripeness of the fruit. It connects how potent the drug is, how long it's been expired. It can connect all of these different things together using this ontology power to really get an understanding of, okay, not just, in general, not for the average person, but at this point in time, how can I better or help myself avoid these drug interactions and help my drug absorption, help my nutrient intake, all of these other things. And that's what this big data can put in store for us. The power of what this food-drug interaction ontology can do is ridiculous. You can define food-drug interactions in this new powerful way, but you also create a basis that you can code around. By coding into this ontology using simple coding languages like Python and JavaScript, you can create amazing new powerful websites or even mobile applications that can inform on food-drug interactions, but also personalize around yourself and ask, how can I, better my own self and make myself healthier by combining my knowledge of food and my knowledge of medicine into this one single application and this one single idea of what I should be doing. So how is this ontology going? It's not going as far as we would hope yet, because the key thing is building these ontologies. You can use other ontologies, these base ontologies, things like Reactome, which has amazing power around human biological interactions. The drug ontology, which focuses on drug ingredients, drug interactions, all these other things. And all of these together create these amazing tools. However, in terms of food ontologies, a lot is still missing. A lot has yet to be defined. Things like ripeness of food. Why do we eat food the way we do? What is the behavior that we undertake when we eat it? How does that behavior affect the concentration of food or the concentration of nutrients that come into our system? And when you have an ontology that describes all of these relationships, you can then fully build this ontology and have all of these programs happen. So what we are going to do with this ontology is we're going to present it at the International Conference for Biological Ontologies in Oregon this summer. And we're going to bring people together to build this ontology. Because as you can imagine, building every single one of these relationships is almost impossible for one person to do it alone. That's why so many ontologies that are out there already are very heavily crowdsourced, and why crowdsourcing collaboration is such a huge thing and a huge step in terms of big data and technology. What it means is that by working together, everyone can contribute to the future of food. By contributing to these massive ontologies, it's simple enough that anyone could learn. I have no computer science background whatsoever, and within 3 months, I was building this ontology from the ground up. It's very simple to do, and anyone can contribute and think about any relationships they could potentially add into it. When you have all of that power coming together from multiple minds, you can create a truly universal and a very well-defined vocabulary that can be coded around to build websites and apps at the same level of power as Google and Facebook to create these amazing things and get them to happen. Because when we combine our knowledge of food with the power of IT and the power of computer science, what we create is a massive wealth of knowledge that anyone can utilize. Thank you. Does anyone have any questions on that? I know ontologies are a little can get a little complex sometimes. So.
So you mentioned you don't have much computer science background, but you're really good at that. How was the process?
Yeah, so how it started is I started by using a tool called CMaps. CMaps is something that you can easily use to build a concept map. I can go back and show you one of those concept maps that we built. So if you look on the left there, that's the concept map that we built surrounding the food-drug interaction ontology. And it has all of these relationships at a base level. Now within each of those linkages and connections, there's a million more things that can be opened up, but that concept map provides a rough draft or a rough base for how to build your ontology. From that point, it was a matter of bringing together all these classes that people have already defined. So each of these classes is defined on the internet and has a definition. So you can download them all together into your own ontology using a program called Protégé. And Protégé can help you build these ontologies and create your linkages, create all your connecting phrases, and attribute some classes to other ones. Once that's done, you upload it to a crowdsourced area where ontologies are built called GitHub. And GitHub then allows you to go ahead and share this ontology with people. They can download it, build it more on their Protégé, and put it back up into the same area. And so everyone doing this all at the same time creates that new updated ontology done by everyone.
So you talked about GitHub. So where does your website that take this?
This is currently stored as a skeleton and as a prototype. It was built using basic languages like PHP, MySQL, HTML, and CSS on a GoDaddy server. However, we're going to be expanding that massively onto a clone server using the power of programs like Python and Spyrou, which is the MySQL database equivalent for Python.
So I guess I have two questions. One being really kind of conceptual and maybe simplistic. There's like a movement where people are seeing food as medicine. So do you have an ontology that kind of deals with that sort of thought?
Okay, and then what was the second question?
And then the second one, would sort of the future of ontologies be providing more personalized medical sort of knowledge to laymen, or would it be for medical professionals to talk to patients about what's going on?
So the answer to your first question is that this ontology is actually considering that. What foods can be used as substitutes, for medicines, because there is that. People think that it can be done, and research has shown that food can be a substitute for medicine in some places. Things like garlic and turmeric have been shown to be very powerful in terms of antibiotics. So this ontology is going to take that into consideration. And then to your second question, it's going to be a tool for both. A tool that medical professionals can use to inform their patients and have all that information there very easily. However, a patient can also take it and personalize their own health based on their food and their medicine and figure out, okay, what food should I be making? What recipes could I potentially find? That could be something in there as well, because the food section of this ontology has things like recipes, ingredients, something that someone could go in and search and figure out how to build a dish, maybe that they would love to enjoy, but has something that interferes with the medicine. Now they could build it potentially without that.
When do you think this technology will be mainstream to the public?
So this technology is already available as a mainstream to the public.
When would the public,
When this ontology would be completed.
or rather, yeah, this ontology, as well as like, when do you see like the public actually using a technology like this?
So the public would be using this in a similar way they would use Facebook or Google and things like that in an application.
Right.
So this technology is something that a coder can harness and use its power in for an app. And anyone who has a coding knowledge in Python, PHP, they can go in and access this ontology using code. And once they go in and access that ontology, that power is limitless. And so once that ontology is completed, which could take anywhere from 2 to 5 years, depending on the level of collaboration, how fast things can be built, and all that other stuff. Once that ontology is completed, it can be used at a very quick rate, and many applications can use it.
What's
Okay.
your licensing system, or is it open source? Is it
Open source. So all ontologies nowadays are built on an open source system, with the exception of what Google and Facebook have.
You answered my question.
All right, that's all I have. Thank you, guys.